Hello everyone, in this video I am trying to discuss about arrays. So to define arrays, arrays are the systematic arrangement of the similar objects in rows and columns. In computer terms, arrays are the data structure which consists of the collection of those elements, and different terms are used for this. They can be vectors, matrices and tensors based on the numbers of rows and columns. So there are 1D vectors, 2D matrices, 3D cubes and higher dimensional hypercubes, and these are represented as EE.array type in the Earth engine. So these arrays are very powerful in computing. They have the flexible data structure and they may be complex as well, sometimes not scaling. So these are used for higher dimensions models, and they are flexibly used in linear algebra. So these terms are 0D arrays or zero-dimensional arrays are scalars, and one-dimensional arrays can be vectors, 2D can be matrices, 3D arrays are cubes, and similarly greater than 3D arrays are hypercubes. So arrays are just the arrangements of data or structures as in the rows and columns, and beyond that it goes even up to n axis, from 0 to n-1, so they can be quite complex. And the shape of the arrays are determined by the length of the axis. That means the products of the axis lengths. These are the way to understand arrays. So in this particular video we are trying to understand the arrays in Earth engine. So these are from the Earth engine guides. So here is the very first codes. So here we have the variable named coefficients, and we are providing this as EE.array. So here we have the numbers enclosed in the big brackets, and then it is followed by commas, and it continues till the very end here. So we have the 6 different numbers and 6 different rows, and this is the way to know or write the arrays in Earth engine. So here we can see the dimensions by coefficients dot length, and we will see this little letter, and we can slice that, or we can take out the needed line by dot slice, starting at 0 axis, starting at 1 and ending at 2. And these are the way to develop the array. So here is this is the first line here. EE.array is providing a single line, and we can add the dimensions in this way. So let us run this first and see. So the first one here, this was the array we developed, and by dot length it gives us that this is the 6 into 6 array. This is the dimension, and then we had sliced it up by dot slice, only selecting that only selecting the single rows from that array. And the last one here was the arrangement of the array. So the first one here was in the single as in the vector way, and then second dimension was added by this addition of lines. So if we see the properties, in the console, we can see that big bracket has been added. And to understand the use of the arrays, there is this particular example called the Tasselled gap transformation. We just saw this here the example of creating this. This is the tasseled cap coefficients, and this tasseled cap coefficients is the best example of the arrays being used in earth sensing or in remote sensing. So this tasselled cap transformation is the way to transform the spectral information into the spectral indicators. So this is used for storing the vegetation. It is generated on the basis of those spectral information from the LANDSAT satellite, and it transforms the spectral information. So this is unique for each sensor. So the main idea what it is that we multiply each LANDSAT bands with some constants, and we get different bands from that. So the tasselled cap band 1 is related to the brightness, and band 2 the greenness, and band 3 is the wetness. So here we provide the array to this variable, and then after we select the bands from the LANDSAT image, and then after we convert this to array. This is the one-dimensional array per pixel, and we also can develop a two-dimensional array per pixel by specifying one of the this function here, dot to array. And for multiplication, we are sure that we need to have some dimensions of these two arrays to be same. So we have this 6 into 6, so the last and the first should be similar for the multiplication, and this is done as providing the coefficients here, and we say dot matrix multiply and provide our another array. So these two arrays can be multiplied in this way, and here we are specifying dot array project, and this is getting rid of the extra dimensions, and we further specify the name to the multiplication, and then after we can print if we like, and the other things are same. So we can run this. So here as a summary, you can say that just multiplying the bands with some constants, this is the main idea. So you can see here, you can see the image first. So this is the false color composite image, and you can see that these different colors mean different. So as defined earlier, so brightness is the measurement value for the ground. We have the band 2 greenness for the vegetation, and the 3 for the measured value for interactions of soil and canopy moisture. So this is the way to use the arrays. So I hope this was helpful. So in arrays there are a lot of things still to learn. So thank you for watching.